Hey guys, it's Mr. Dugal, and today we're going to talk about irrational numbers. And irrational numbers are numbers that cannot be written as a ratio. And you'll see here we say as A is to B. So irrational numbers can't be simplified down to a ratio. We're going to go through a couple examples and try to clarify what is an irrational number. So our first one is 1/2 right here. And I bring this up just because it is already written in a ratio. So when we say that it needs to be able to be simplified to a ratio, it means I'm able to simplify it down to a fraction where it's some amount of numerator over some amount of denominator. So in this case, I have 1/2, 1/2 is the ratio, and therefore this is rational. Okay, our next number up is the square root of 9. Square root would be what times itself equals 9. When I solve that, I realize that the square root of 9 is 3. And 3, while it is a whole number, can still be written as a ratio. It still does have a denominator, even though it's not present right now. And that denominator is 1. So the ratio would be 3 per 1, 3 per every 1. Not only is this a ratio, it's also a unit rate. Obviously, this is rational because it can be simplified down to a ratio. Next up, we have 0.3 repeating. So this would go on, obviously, forever. This is a repeating decimal. Sometimes people will get repeating decimals and irrational numbers confused. And while our irrational numbers do tend to repeat, not all repeating decimals are irrational. It's almost the same kind of idea that all squares are rectangles, but not all rectangles are squares. That's kind of how it is with irrational numbers, where all irrational numbers do repeat, but not all repeating numbers are irrational numbers. So here we have 0.3 repeating. I chose that is pretty commonly used as a repeating decimal because most people know the ratio that it simplifies down to. And this ratio is 1/3, 1/3. Because it does simplify down to a ratio, this is rational. Our final one we have here is the square root of 15. As I go through my perfect squares, I notice that I have 3 squared right here was 9. And my next one up is 4 squared, which is 16. So if I were to estimate the square root of 15, I would know it's pretty close to 4. It's not quite 4, it's in between 3 and 4. But 15 is closer to 16 than it is 9. So I know that it's almost 4, and all radicals or all square roots that are not perfect squares repeat. So therefore all non-perfect square roots are irrational. They will all repeat, and they are all irrational. And this is our most common irrational number. A square root that is not a perfect square. So, for example, the square root of 25 would be rational. It simplifies to 5, which would have a ratio of 5:1. However, the square root of 26 is not rational. It's not a perfect square, it's a little above 5, and it repeats forever. Therefore, the square root of 15, and actually the square root of 26, are irrational. As you continue into secondary math and into high school math, you'll get into other irrational numbers. I do just want to point out for now, one irrational number that's pretty common is pi. So a lot of times when we find circumference or area of a circle, we use 3.14. Tests and teachers will tell you, oh, just use 3.14 for pi. And that's because pi is irrational. So what we need to know for right now is that all non-perfect square roots are irrational and that pi is irrational. And those are really the ones that we need to know for the present. One other thing to note with irrational numbers, so with our irrational numbers of non-perfect square roots in pi, for example, all of these numbers on here, both our rational and irrational numbers present, they are all what we call real numbers. So both rational and irrational numbers are real numbers. And for right now, just know that there are such thing, and I know this sounds like a joke, but it's real. There are such thing as what's called imaginary numbers. And I just want to point out for right now that none of these are imaginary numbers. That even irrational numbers and rational numbers, they both are real numbers. You'll learn more about imaginary numbers in higher level high school math. But for now, just know that an irrational number, while being different than a rational number, they both are alike in the way that they constitute our real numbers. So that's about it. Hopefully this helps as a solid foundation into distinguishing between irrational numbers and rational numbers. Thanks so much for watching.